In this video, I'm going to talk about arithmetic sequences. So an arithmetic sequence is just a sequence that has a starting number, and then we're just going to change every term by adding or subtracting the same value over and over and over again. So we have a nice formula that we can work with, and the formula goes a sub n, which just means the nth term if we're looking for a particular one, equals a sub 1, which is the first term where we start, plus the difference between each term. We're going to multiply it by this quantity n minus 1, where the n kind of tells us the nth term that we're going for. So the n is like, if we're going for the 30th term, a sub n is the value of the 30th term, while n is just the number 30. Okay, so, and again, our arithmetic sequences, I'm kind of talking about things like, if we start with like an 8, and maybe we're going to add 6 every time, so it'd be 8, and then 14, and then 20, and 26, and 32, and so on, right? Because we're starting at 8, and we're just adding 6 to every single term as we stroll through, and it just does it forever and ever. So if we were going to take this idea of starting at 8 and adding 6 every time, I could use my formula where my a sub 1 is my starting point, which was 8, and my d was my difference between each term, and that was a positive 6. Okay, so I have these two values, and really those two values are sufficient for writing an arithmetic sequence, because all we really need to know is where it starts and how to change between one term and the next term. So if we shuffle back over and look at our formula, we knew that a sub 1 was 8, and that was my starting point, and my difference was 6. I'm adding 6 every time, so plus 6. And then in my formula, I just had this quantity n minus 1. That just goes there all the time. And then it's going to be equal to this a sub n, right? So I have written my formula here where we're saying a sub n, which is some nth term that we're looking for, equals 8 plus 6, which is the difference between every one of them, times this quantity n minus 1. Well, why does this n minus 1, why do we put it here? Why is it here? What is it good for? What does it do? How does it affect it? Okay, so lots of good questions. So let's think about our very first term. So our first term is a sub 1, so that means our value for n is 1, so 8 plus 6, and then times this quantity 1 minus 1. Well, 1 minus 1 is 0, right? So 6 times 0 is just 0, so that all goes away. So my a sub 1 is just my 8. Well, I know if I'm going to have a sub 1 as my starting point, and I'm going to put it here, then all of this stuff has to go away to maintain the integrity of my starting point. So this idea of 1 minus 1 makes it go away. Okay, so that might be a little confusing. Let's think about trying to find my second term. So a sub 2 is going to be 8 plus 6 times some quantity, n, which is 2 again, minus 1. So 2 minus 1 is 1. 6 times 1 is 6, so 8 plus 6 equals 14. And we're saying this is going to be a sub 2, or my second term. Right, well, if we jump back up here, we notice we start with 8, we add 6 one time, and we get 14. So think about this for a moment. If this is my first term, and this is my second term, and third term, and fourth term, and so on, right? How many times do I have to add 6 to get to the second term? Well, I just do it one time. How many times do I add 6 to get to the third term? Well, twice, right? So if I'm heading to some n term that I don't know, how many times do I have to add 6? Well, based on this, I have to add 6 one less time than the number I'm shooting for. I'm going for my second number, so I add it once. My third number, so I add it twice. My fourth number, so I add it 3 times. And that's kind of where this n minus 1 comes into play, is because the number of times I'm actually adding 6. Because how many times do I add 6 to my 8 to get my first term? Well, of course I don't add it at all. So that's why this ends up canceling out and going away. So let's look at another example to help solidify our idea of what's going on here. So I have rewritten my formula for my arithmetic sequence, and it's just going to be my nth term equals my first term plus the difference between the terms times the quantity, just n minus 1. We talked a little bit about why that n minus 1 is there. So let's say we have this formula right here. So we have the nth term equals negative 5 plus 4 times the quantity n minus 1. So this is kind of telling me that my a sub 1 is my negative 5, so we can say my first term is negative 5, and my difference every time is a positive 4, so we're just adding 4 every time. So if I was going to write the first 4 or 5 terms of this sequence, negative 5 is where I'm starting, and I'm adding 4 every time, so negative 5 plus 4 is negative 1, plus 4 more is 3, plus 4 more is 7, plus 4 more is 11, and I could just continue that forever and ever. But ultimately, I'm starting at negative 5, and I'm adding 4 each time, just like that. Or maybe we were thinking about, well, what is, say, the 36th term, right? So that means my n value is 36, since I'm looking for a sub 36, the 36th term. So it's going to be negative 5 plus 4 times, well, 36 minus 1, because I only have to add 4, 36 minus 1 times to negative 5 in order to get my 36th term. So when I do this, it'll be negative 5 plus 4, and then, of course, 36 minus 1 is 35. So negative 5 plus, well, 4 times 35 should be 140, and negative 5 plus 140 should be 135. So I'm saying that my 36th term of this sequence is going to be 135 if I would just continue this over and over and over until I got to my 36th term. But of course, doing this 36 times, not awesome. So we have a nice formula we can use to just put in our formula, simplify, and we just know what the term is going to be just by using our formula. Our third and final example is a little bit of a word problem here. It says a sequence starts with negative 2/3 and adds 1/3 to each subsequent term. So it just means add 1/3, add 1/3, add 1/3 over and over again. Find the 62nd term of such a sequence. Okay, so if it starts at negative 2/3, I know my a sub 1 is negative 2/3. Also, if we're adding 1/3, that means my difference is going to be a positive 1/3. So I can kind of now use my formula, a sub n equals a sub 1 plus d times the quantity n minus 1. So let's go ahead and plug my values in. A sub n should equal my starting value, negative 2/3, plus 1/3 times this n minus 1. And since we're looking for the 62nd term, my n should be 62. So a sub 62 equals negative 2/3 plus 1/3 times the quantity 62 minus 1. And then it's really just a matter of simplifying this expression. So 62 minus 1 is 61, and then 1/3 times 61 should be just 61 over 3. So if we have a sub 62, that equals negative 2/3 plus 61 over 3. Really, it's just a matter of adding these two together. Okay, so negative 2 plus 61, since they already have common denominators, is 59 over that common denominator of 3, and that's going to be my a sub 62. So we're going to say my 62nd term of this sequence is 59 over 3.